Okay, your final thing is to make sure you can connect your equations to the slope. And here's how we do it. Let's say we have something like y equals 2/3 x plus 5. Here's your equation, and I'm going to ask you to graph it and give me the slope of that equation. Well, when we do this, we have, we graph it just like normal. Let's get a couple of points. Stick in 0, that's the easy one to stick in. We stick in 0 for x. We have 2/3 times 0 is 0. Plus 5 is 5. Y equals 5. So 0, 5 is one of them. It's kind of nice. And stick in another point. I don't know, 3. 3 is kind of a nice one. You could stick in anything you want, but 3, 2/3 times 3 is 2. Plus 5 is 7. So when you graph it, you have 0, 5, 3, 7. There's your line. Now, the slope. How do we get a slope between 2 points? We're going to take m equals 7 minus 5 over 7 minus 5 over 3 minus 0, 2/3. Slope of this line is 2/3. Let's try it again. Y equals negative 7/9 x plus 18. Let's draw a little graph here, a little chart, x, y. So if x is 0, y equals 18. Stick in a really good number that will get rid of that. Stick in a 9 for x. Those cancel. We have negative 7 plus 18 is, oh, that would be 11. So you can graph this. 0, 18, then 9, 11. The slope is going to be 18 minus 11 over 0 minus 9. 18 minus 11 is 7 over negative 9. That's negative 7/9. Now, we could do this over and over. And some of you will think, I think I see a pattern. Brother Baird, stop. 2/3. 2/3. Negative 7/9. Negative 7/9. Is it possible that we could skip this whole thing and I give you this? Y equals 3/8 x plus 27. Could you give me the slope of that? You're like, well, if that pattern holds in the slope, it's going to be 3/8. You are correct. If y is by itself, the slope will always be sitting right in front of the x all the time. In fact, it's so common they write it like this. They say the m is right in front of the x and they put this other thing. This number, you'll notice, was always the y-intercept. So here's the slope here. Now this is if y is by itself. The slope is there. And here's the y-intercept. So you have the slope and the intercept just sitting there in the equation. So it's called the slope-intercept form of the equation.
Let's see an example of how to use this tool as a method for graphing.
Most students prefer this method when we survey students and they learn this. They like this method. It's fast and it's effective. So let's spend some time learning this. One of the things that this method does for us is it helps solidify our knowledge about the y equals mx plus b equation. And you've already learned that. And so if I have the same equation, again, I want you to look right here. We did this with the plug and chug method, and we did it with the intercept method. And I left this up here because I want to show you that these graphs are indeed identical when we graph using the y equals mx plus b method. So step number 1 in the y equals mx plus b method, equation in y equals mx plus b form. In other words, get y alone. Solve for y. So if we have 2x plus 3y equals negative 6, and my goal is to get y all alone, then what are the things I need to do in obeying the balance rule? We learned this when we solved formulas. Okay, so we're going to subtract 2x. Good idea. I like it. And what we do to one side, I must do to the other side. Subtract 2x. Okay? These will cancel, and we're left with 3y equals. Now in the past, we've written negative 6 minus 2x. Is there a difference if I write negative 2x minus 6? there is not a difference. These two are the same, okay? And why do we want to write it in this form down here? Because I want this to be in y equals mx plus b form. I want my x term to be listed first. So the signs of these terms go with them. This is negative 2x and negative 6. Now, who is sharing sides with y? 3 is. Good. And it's being multiplied. So we're going to divide, and we're going to divide this by 3. And again, in the past, we've often divided this whole side by 3. But we've learned that we can, okay, divide each of these terms by 3 and equal the same thing. And this is, again, important because we don't want to unite mx plus b. We want them to be individual because they're going to communicate something to us very important that allows us to graph this line. Now the 3's cancel out, and this just becomes y, and we have achieved what we need to in terms of getting y alone, and I'm left with negative 2/3 x, and then 6 divided by 3 is 2, so we have minus 2. Okay. Good job. Now let's think about this. This is of the form y equals, let me grab another pen here, y equals m x, okay, plus b. So if we look at this, what is m? M is, that's right, negative 2/3. Very good. Okay, so you, by putting this equation from this form here into y equals mx plus b form, I want to re-emphasize this. This equation right here and this equation right here, they look different, but they are the same equation. One is in what we call standard form, and this is in y equals mx plus b, or slope-intercept form. So the slope is 2/3, and we can see b is equal to negative 2. Now, do you remember what b is? We learned this. b is your, that's right, it is your y-intercept. So this is not just simply negative 2, but it's an ordered pair. This is, okay, 0, comma, negative 2. So step number 2 here says plot b. Right now, we have 1 point. Okay, this is our first point. How many points again do we need to graph a line? That's right, 2 points. So our first point that we achieved by putting this in y equals mx plus b is there sits in the very equation, our first point, the y-intercept. So we can come over here and we can plot this. We can say, are we on the y-axis or the x-axis? That's right, we're on the y-axis. This is negative 2. There's our first point. Now, it states our last step here says use m. M is our slope. And slope by definition means rise over run. So let's look at this right here. This equals, don't mind, I'm just going to write this here, rise over run. Okay? So our rise is negative 2, and our run is 3 in our slope. Does rise mean to go up? In math, it can mean to go up if it is positive. It can mean to go down if it's negative. And run, does run mean to always go forward? In math, it means to go forward if we're positive. It means to go in reverse if we are negative. So let's go ahead. We need a second point. So look at this. We're using m to rise and run from the point B to get our second point. Let's come over here. Here we are. This is B. And we want to rise, which could mean to go up or down. And our rise, if we remember, our rise over there equals negative 2. And our run equals positive 3. So we are going to go down 1, 2, and we're going to run 3. So we're going to go forward 1, 2, 3. Very good. And now we have 2 points, and we can connect them. and we have our line. Now let's look at these two lines. Do they look the same? They do. That's awesome. Good work.
To the boards! Welcome back to the boards. It's time for you to get some practice problems in. We have been learning how to graph in y equals mx plus b format. And so we have 5 questions here, 1, 2, 3, 4, 5 that we would like you to do. When doing these, make sure to follow this 5-step procedure. Step 1, get y by itself. Step number 2, graph the y-intercept, which will be the b in y equals mx plus b. Step number 3, from that point, from the y-intercept, use the slope, that's the m value, the number with the x, and do rise over run to get to the next point. Step number 4, connect those points with a line. Now it is possible that you'll have to apply step number 5, which is if you only have the letter y, the variable y, the line is going to be horizontal. And if you only have the letter x, then it's going to be a vertical line. It's time for you to practice. Pause the video now and give these 5 a try. When you're ready to check your answers, unpause it and we'll work on it together. Good luck! Okay, let's take a look. Question number 1 is y equals 3/5 x minus 2. Step number 1, solve for y. Notice my y is already by itself, so I don't need to do that. Step number 2, I need to graph the y-intercept. That's the b value. So this is y equals mx plus b. So my y-intercept is -2. So I'm going to go to the y and put a -2. Step number 3, I need to find the slope. The slope is the value with the x, the m. My slope is 3/5. Now that represents my rise over my run. So from this point, I need to rise 3. 1, 2, 3. And then I need to run 5. 1, 2, 3, 4, 5. There's my next point. Step number 4, connect those dots. Those points, once we connect the points, we have a line, and that right there is my answer. Let's try the next one. Question number 2. 4x plus 2y equals 8. Step number 1, we got to solve for y. Yep, y is not by itself, so I'm going to minus 4x to both sides of the equation. So I'm left with 2y equals -4x plus 8. My y is still not by itself, so I need to divide everything by 2. Divide by 2. When I do that, I get y equals -2x plus 4. Okay, good. So now I have solved for y. Y is by itself. Step number 2, I need to graph the y-intercept, the number that's not with the x. So that's a 4. So right here's my y-intercept. So I'm going to do a 4. Good. Next thing I need to do is from this point here, I need to use the slope. Now the slope is the number with the x. So this is my slope, the -2. So I need to rise -2. Oh, rise -2. So that means go down 2. In fact, it can help to write this as a fraction if you want, so that you can see the rise is -2 and the run is 1. So I go down 2/1. And then we connect. And that's it. Okay, good. Number 3. On question number 3, first thing we got to do is solve for y. Y is already by itself, so check. Graph the y-intercept. Now this is a weird one because it's y equals 3x. There is no plus b. In fact, we could come in and put plus 0 here if we wanted to. That would tell us that the y-intercept is at 0. Since there's no number here, see over here we had a -2 and here we had a 4. Those were the y-intercepts. There is no number, so my y-intercept is 0. From that point, use the slope to get the rise over the run. So this is a 3. I could put it 3/1. So from this point, I need to rise 3, run 1. So I'm going to go 1, 2, 3/1 and connect. Perfect. That's the answer to number 3. Number 4. I need to get y by itself. And step number 1 is solve for y. Y is not by itself, so I'm going to divide both sides by 2. I get y equals 7. Oh, now this is weird because there's no x. So I'm going to skip these steps here and go to step number 5. And remember that if you only have a y, which is what we have here, there's no x, then the answer to this question is horizontal. This line is horizontal because there is no x. So I'm just going to go up to 7 and do a horizontal line here at 7. Remember, when it's y equals and there's no x, then it's a horizontal line. Okay, next one. Last one, I've got x equals -9. Now this is weird because we can't even solve for y. There is no y. And so I'm going to go all the way down to the last step. It says if you only have an x, which is what we have here, then the answer is vertical. It's a vertical line. So I'm going to go to -9 and do a vertical line here at -9. And that is the answer to these 5 questions. Thanks for going to the boards. Keep working hard in the section.
And now we have some instruction on how to use the standard form of an equation and use the shortcuts relating to that form. This is not required as a section and is optional for those students who would like to know how to use it.
So if you get something, 3x plus 2y equals 18. And you say, okay, let's find the slope of that line. You could go through the whole thing, get an x and a y, subtract them, and find out what that slope is. Or, since you already know that if you get y by itself, slope will be right there, you can do that. You can say, aha. So if I subtract the 3x over, why do we write the -3x first? I don't know. We just subtracted the 3x over, then we divide by 2. 18 divided by 2 is 9. Can you tell me what this slope is? It's right there. So you can change it into this. Or you can start, after you do that a few times, well, let's do it one more time and then we'll see a pattern. 5x minus 8y equals 16. So, finding the slope of this, well, we can use that pattern over there. So let's subtract 5. And then divide by a -8. That's gone. So we have y equals 5/8 x minus 2. What's the slope? 5/8. So you look at that and you're like, oh, there's a pattern that always happens. Always. -3/2. There's a 3 and there's a 2. When things are written in standard form, they are written with no fractions. That these numbers right here are integers. If you remember those are the nice ones. No fractions, no decimals, nothing. If it's written like this, we can follow this pattern. Let's do it one more time to make sure we can do it. Let's get y by itself. Subtract the ax. Notice that minus sign pops up. And divide by b. The slope will always be, I'm going to say over b. Now you may ask, why in the world does this help us? Let's do a couple of examples. Now that we've got that. So, right here, we know a really easy point. If we stick 0 in right there, we have -5 as an intercept. That's automatically one point that's really, really easy to get. Now, we also know that the slope is 3/8. So on that top one, the slope is right in front of the x because the y is by itself. So that means from this point, we could go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There's the next point. You don't even have to know what it is exactly. I mean, we could find out if you go up 3, you're at -2, and you're over 8, so 8, -2 is the point. But that's how steep it is. If you have a point and you know how steep it is, that gives you the entire line. So you're able to use that to graph a line kind of fast. Let's do another one. Y equals -2x plus 5. Okay, so really quick, if you stick a 0 in, get 5. That's why slope-intercept is so nice. There's the intercept right there. And the slope is -2. Now, any number can go over 1. So it's -2 over 1. And you have 0, 5. Now, this means it goes down 2 for every 1 it goes across. You can go down 2, 1 across. And there's your line. So it actually goes kind of fast. Now, some of you may think, oh, so I go up 2, but then you have to make sure and go back 1. Either way, you'll get the same line. When you're dealing with the negative only goes on either the top or the bottom. If you put a negative on both of them, it would cancel and you'd have a positive slope. But this is a negative one going down. Let's do a couple with this standard form that's a little bit harder to pull stuff out of in some regards. So we have 5x plus 3y equals 2. Now you'll notice it's not really easy. The intercept doesn't just pop out at you. You have to think about what problem might be good. In this case, you know that 5 minus 3 is 1, so we could have a point. If we took 1 minus 1, that would give us an x and a y that would work. So there's a point. We found one. Now the slope. If you look at this, anytime you have a number in front of x and a number in front of y, the slope is the opposite of the first over the second. So the slope is a -5/3. And that's the shortcut. Now you could change this into slope-intercept and it would work fine. So we have 1, -1, and the slope from here is down 5 over 3. Oops. There we go. Alrighty, let's try another one very similar to that. Minus. Okay. So, we need to get a point first. The y-intercept isn't so nice. The good thing about standard form is you're able to pull out the x-intercept really easy if you'd like to. Stick a 0 in for y. If that's gone, can you get x by itself? X is 4. 4 times 4 gives you 16. And the slope is the opposite of 4 over -7. So that means we have positive 4/7. So 4, 0, and up 4 over 7. There we go. So you're able to graph lines fairly quickly if you can pull the slope out of the equation fast. All you have to do is find one point and you're able to graph the other ones.